Hi everybody, welcome to our different time of 3 p.m. talk with Dave Finster. He's a UQ alumni currently working at Google. I'll let him take over and enjoy the talk. Dave.
Thank you. And hi, everyone. Thanks for accommodating me at, yes, a different time. If I'd kept the regular one, it would have been midnight for me over in San Francisco. So definitely nice to take some time out of the day. As you've probably seen in the advertising material, this talk is called Cloud Deployment, Operations and Capabilities, kind of an extension of Tom Manderson's talk about starting with an application and moving it to a remote machine for it to run. I want to dive in a bit deeper to show off what things you can achieve by rethinking or extending how you package your application and how you think about it, and what the cloud can enable for you. So, quick, who am I? I'm DF on Slack. You may have seen some of my ranting or stirring over the years, and I swear it, most of it's in good jest. I am a software engineering grad from UQ as of December 2011. But during university and since, it's about 13 years, I've moved between all different sizes of company and have now wound up working for Google over here in the US. I have always been a bit of a generalist. So I've moved between things like software development and delivery to managing a team within a large multinational, to tinkering with telecommunications, networking, and WAN delivery. So overall, the things that have interested me is essentially everything to do with actually delivering a product end-to-end for folks. Particularly the networking and telecommunications side, coupled with software engineering, led me to join my current team at Google, host networking, site reliability engineering. So we look after the networking stack on every production machine in Google's fleet, which is known as the core product known as Snap, which I'll release the slides after this. There's a link there, or you can just look it up. It's a attempt to shift networking out of the kernel into user space and allowing the rapid upgrading and development of new networking features across the world. So, why should anyone ever consider cloud? I said on my first slide that sometimes it's more than just someone else's computer. And if you embrace the additional services around it and a different way of thinking, it really can be. I see it as more as a different way of approaching software development and the infrastructure required to provide services to customers and people. The actual spirit is more leaning towards things like automation, fully repeatable builds, and things that you can just look at a repository and produce an artifact from there reliably. It's to improve visibility so that you, as either an operator or a developer, or someone working in DevOps or someone working in SRE, can get a better understanding of how your application behaves in reality. And also through these mechanisms, hopefully achieve better reliability, because ultimately software that doesn't work well for customers tends to have limited use cases, particularly when a company needs to stay alive. It's also a case of by having resources available on demand and available via APIs, meaning that you can develop against it and write everything from scripts to complex automation to manage your infrastructure, there is less and less room for manual intervention, or less and less reason why you have to be the one to set up a machine and get it in exactly the right state before you can put your application on it. Cloud providers across AWS, Azure, and GCP, among others, provide a lot of tools as well. So this isn't just running a VM or something. or a database, there is usually an entire ecosystem, not only from the providers, but also from a lot of third parties. The provider ones tend to have certain advantages, but which we'll show a little bit in this talk, but you can also have the option to avoid being locked into any particular vendor. Probably the one project that is core to what the industry does today is, or the way the industry is going today, is the Kubernetes project. And it has really taken what Docker started and turned it into the container revolution into something that even enterprise IT is now quite happy to consider. So we start with my very artistically beautiful depiction of a modern application. And this is sometimes how we think about it. It's just this one little box. But in reality, it's a lot more. To actually run an application, unless you're writing everything from scratch, you're going to have some libraries underneath. And then beneath those, they're going to potentially either use, or your application is going to directly use, libraries that come with the system. And then beneath that, there's a system call interface that is used to talk into the kernel. So there's actually a couple of different things that you have to keep in sync, right? You have libraries that your application directly uses. You can manage those, but sometimes system libraries stomp each other, and it's not fun. Or someone in IT operations upgrades to a new kernel that the thing doesn't work with, which changes system call interfaces or has a bug in it. This isn't always fun to discover at 3 a.m. And then beneath the kernel, we also have the machine that we need to consider. So in a large company, you have different teams that look after storage and networking, the hardware of the machine, data centers, and everything behind that. That can be a very daunting thing when you're a lone developer or in a very small team, and it can at times feel like everything's stacked against you. But we can ask ourselves what an application really wants, or what you as a developer probably want in order to get your stuff running. And the reality is that your applications want their libraries, which is not just the ones that you bring in with your favorite package manager, but also ideally a snapshot of the system libraries, so that you're not having to worry about someone else showing up and overriding it. Often, at least in modern times, they'll want network access as well, either to talk to other servers or to provide services to other clients, so be it databases, users, whatever. And often, any real application is at some point going to need to store data persistently. So while a lot of these things are already provided by a system today, they're at risk of, each application is at risk of interfering with each other, or they're a shared state, which, again, anything could mess up, or if there is an issue, potentially affect multiple applications all at the same time. So maybe we can think of a different way of packaging an application. And I'll point out that this is a bit of a whirlwind tour of what a container is, but it is just an example of thinking of an application as a consistent building block that we can then deploy into a cloud environment or to a consistent environment. So a container allows us to describe and capture the system level interfaces that we would want to express for our application. We can give each container a fairly isolated view of the world, and it can declare the things that it wants the system to provide in a reasonably consistent way. The image itself is actually just a snapshot of all of the files needed to run that application. So that will be everything from your binary down to the system libraries and everything in between. If we throw in a way to reference these containers or these images, then we also have a means to version them, like you would any artifact or source control system. And by providing this consistent way of representing not only the application, but also the way it connects into the infrastructure that runs it, we can actually, as developers, step away from needing to worry about the underlying components if we end up in a position where automation can provide us with an environment that these things can run in. So instead of trying to run machines and have a set of VMs or physical servers that we need to massage into the correct state, maybe instead we can just focus on running applications, and the infrastructure can provide us with a better way. And that is exactly what Kubernetes does today. It's what Docker set out to do. But in my opinion, Kubernetes is the current leader of it as sort of the industry standard for running containers in production environments, largely because it's incredibly extensible and well supported. By documenting our requirements for our applications in this way, the infrastructure can actually achieve a lot of the manual effort that would have needed to be put in previously to get things running. So to help demonstrate this, I built a demo application, as all these things must have, that consists of a standard 3-tier of front end, which provides HTTP services out to the real world. It speaks gRPC to a backend that, again, I wrote. And then the backend talks TCP and PostgreSQL protocol back to a Postgres database. It's incredibly simplistic, and the code will be available after the talk. It's nothing special, but it'll hopefully show off some of the features that I'm referring to. So I know that was a whirlwind tour, but hopefully as I go, I'll be able to just show you practically what all of that rambling was actually for. So I will show off one particularly neat feature that is seldom known for GCP, which is you can actually get a cloud VM that is managed for you by GCP that provides you with a shell, a bunch of pre-installed things, and a code editor, like this one. And it's not just a basic text editor. It does Go auto-completion and a few other things. And this even provides a bunch of pre-installed tools, like the Kubernetes management tools. And there's even a fully fledged Docker engine running in this thing, which can be used to build images. And this is a free thing, up to, I think it's a 40-hour usage limit per week. And you can also boost it so that it's assigned more resources and you get a more powerful VM behind it, which is very useful if you're trying to do some compiles or the Docker builds are particularly onerous. All right. So as a demonstration, I'm going to deploy my basic application. And we start off in the GCP control panel and inside Kubernetes engine. I've already got this cluster provisioned, largely because some of the componentry can take odd amounts of time to get set up. So I didn't want to chance that during a live demo. But as some of the, sure, that's that. So when you create a cluster, you can experiment with this in lots of different ways. We actually provide this. I'm not sure how useful it is for testing things like high availability, but it's actually quite easy to step through the creation process just by providing a name. We can actually also configure a cluster to be either zonal or regional. So regional means that we spin up multiple Kubernetes masters and you can expect and you can have nodes in many zones within a single region, which is the best way to achieve a resilient cluster. And as part of that, GCP will actually provide lots of automation and management of the Kubernetes cluster on your behalf. So we can do things like auto scaling, which will tap into CPU utilization metrics that are automatically collected, and if need be, spin up additional VMs for you. And as new versions of Kubernetes are released, or the nodes that you have start to show issues like unstable kernels or other weird bugs, auto repair and auto upgrade can take nodes out of service or provision new ones before you ever see an issue. They're all also configurable. This is a pretty standard thing. You can choose how big you want your VMs to be within a cluster, and you can have a cluster that mixes different types, and you can schedule workloads on machines depending on how much capacity they've got. Something that is useful for experimentation, I will point out, is preemptable nodes. There's an extra benefit in Kubernetes for these. And essentially what they are is they are spare compute capacity that exists within GCP that didn't get sold at the normal rate, on-demand rate. So as a result, you usually get about a 50 to 60% discount for running these things. The trade-off is that they'll be shot every 24 hours. But as long as there is still spare capacity, the Kubernetes subsystems will create a replacement node and put your applications back on it. It can be a really neat way to experiment in a really cost-effective way. The neat thing being that you also inherently test your cluster's resilience because nodes will get shot. Thus, everything has to come back to a healthy state. That's not particularly useful. There are some more advanced networking features here that probably don't need to be covered, but I'm happy to answer questions about them if folks have them. There is one neat networking feature that I'll point out further down the track, and which will probably be it's a bit of a distinguishing feature of GCP. All right. So we're going to start with this. Cool. So this seems like a pile of incomprehensible YAML, which is pretty standard for the course. What this is actually, I'll go through what this is actually collecting. The first piece is my backend, the piece that I have gone and built. It's identified by a few things. This is the image that I built as part of a Docker build process. These are some environment variables that I want Kubernetes to provide to my application. These are ways for Kubernetes to detect when my application is ready to serve real traffic and users. These are the resources that I want Kubernetes to set aside for this particular application. And these are the services that my application exposes out to the rest of the cluster. So if you remember back to my previous slides, this is all methods by which I'm describing to my infrastructure how or what the requirements that my application needs from the system. There is also a shim, we'll say, to allow my application to talk to a GCP Cloud SQL. This is largely implementation detail. So they're the containers that I want Kubernetes to build, but it actually provides a lot more than that. Up here, I'm actually wrapping these containers inside a deployment. So the deployment is actually a more intelligent manager over the top of a group of containers and can handle things like replication of them and graceful upgrades to an extent. And there's a couple of identifying labels. And then I have my service, which is taking the exposed piece of my container and advertising it to the rest of the cluster, which then anything else running in the cluster can use this to find my backend service. So I'm going to go ahead and deploy that. Yep. The GCP actually provides a custom dashboard essentially for a Kubernetes cluster under its management. So in here, I can get a bird's eye view of the deployment, and these metrics are actually automatically collected. So I get a CPU, memory, and disk usage breakdown of the containers that are running to provide this deployment. And I can also see how things are intended to talk to these containers, or what services these containers are involved in providing. And I can get full, say, revision history of things that have happened to this thing, making rollbacks easier, and basic details. The YAML piece is essentially what I just submitted, but also captures a lot of current state stuff. The advantage being that you can look at a Kubernetes deployment, grab most of that, and then take it to another Kubernetes cluster, put that in there, and it will likely come to the same state. So we'll now do the front end, which is largely the same, except, of course, it's providing HTTP instead, and has a slightly more complicated service because it's facing to the outside world. So run that one. I did already have an old version of this one running. So this is an example of a deployment transitioning between two states. It'll take some time to ensure that the old ones have a graceful chance to gracefully shut down, and while it brings up the new one. So I'm going to do a small demo of something else. So I'm going to hit this small container with a basic load test. Seems to be happily just going along. It's getting hit with 50 concurrent clients, and everything seems pretty stable. I look at what's currently running in the cluster. I pick out my front end, delete it. And things get very sad very quickly. To be expected, right? We're only running one of these things. But in the failure window, Kubernetes has already gone and now has a replacement container running. I mean, this is okay, right? We're only running one thing. We want to replace the one thing or upgrade the one thing. Sure, that's to be expected. But we could probably do a bit better than this. We can probably change this to just be 5, which will give us actually 5 copies of this thing. So we actually obtain some resilience. So this can either be done with a YAML change, or we can just go into the GCP control panel itself, and under actions, you hit scale. I want 5. And I wish this were as easy for complex services as I just made that look. So Kubernetes is quite happily going through and creating a bunch of new things. Cool. Now if we rerun this, I pick out some poor sucker. Yep. Better. We also had no failures this time. Not because we have what GCP has gone and done is provided us with a load balancer out the front, which is actually aware of the pods that are running within our Kubernetes cluster. Now I can actually get some more information from these things because the cloud platform will actually surface information about what's coming in and what's hitting your load balancer. And we find ourselves dealing with some American-based queries, which is where my load tester is running from. And it gives us indications that things aren't healthy, but yeah. The fact that it's hitting a valid backend means that it simply hasn't realized that a pod has ceased running. So we can improve this further and actually even upgrade these applications without any downtime. So we run this instead. So I've taken it back to just having one replica. I'm now going to scale this back up to 5. And figure out what version it is not running, so 3.1. I'll use the cloud platform itself to do a rolling update. So let's just see what this thing looks like normally. Okay, nice and stable, 28 ms. Can live with that. Everything's healthy. I'm going to do a rolling update. Put the version that I want it to go to in here. And Kubernetes can actually handle this quite gracefully. I'm telling it that before you consider a pod ready or a replacement pod ready, I want it to wait at least 10 seconds for things to shake loose and things to start working correctly. The surge allows Kubernetes to create new containers that in place of the old ones before it deletes them. So allowing a temporary surge in capacity usage in order to fulfill availability targets. And I've told it that under no circumstances is a pod or container that's considered serving allowed to be unavailable. So we'll kick this off. It's load test. And tell the start date. And this should be a fantastic demo. Cool. So we've already got 3 of our 5 replacement pods running. And as far as our external user is concerned, nothing has changed. And despite the red, it's actually fine. They're being killed. Right, and that's essentially a whole new version of our application deployed. But as far as the public-facing user is concerned, there was no impact. And that allows for essentially zero-time upgrades of a production environment with essentially some declarative YAML. And I'll make all of these available as well in open source. I just need to scrub them of some things eventually. So with three files of YAML, this one, and I had to do this once. You can have a fairly simple piece of infrastructure that years ago would have been very difficult to achieve, or you would have had to stitch together a lot of your own bash scripts. So that's a kind of a quick whirlwind tour of some pieces that Kubernetes can provide directly. Expanding more into what a cloud platform can do for you, though, is something like actual insights into what your application is doing and how it's behaving. So I'm actually able to, because I've gone and integrated a particular library, I am able to get tracing information about the requests that are being handled by my services. And not just very basic things. These are events that I've tagged. And keep in mind that the front and back end are two completely different processes that could be running anywhere. So the fact that it's able to trace the request across those processes is an incredibly valuable thing. It allows you to figure out what's taking so long. And even more detailed information can be fetched and grouped in with it. So I have this set to provide every single trace for every single request that comes in. Typically, you'd run this with sampling. In the, say 10, 20% of your requests are sampled, or you do some more intelligent things like only the errors. But this is just to demonstrate what's possible. And from here, I can see if this were to fan out further, I'd get more information or more overlaps on the timeline. GCP will actually provide logging for you, so log collection, indexing, and a full query language. These are essentially, there's a very healthy free tier that underpins this, but it's also relatively inexpensive to run on a production environment. And I did most of this as a result of some very hacked together code that is by no means clean, but if you're building your own application, it could be made to be clean. So I wrote it in Go, if you recall. And yeah, sorry. So this is actually using a publicly available framework called OpenCensus, which has just become OpenTelemetry. And there's some setup stuff that you do at the beginning. But the important pieces are within your handlers, or wherever you want some activity to occur that you want to track, you can create custom spans, which are intended to last the entire life of that operation, regardless of where it might end up, either in that process or another process. And I use these a lot in my day-to-day job when I do performance analysis, because even though they're sampled, they provide a really good picture typical performance, and also where bottlenecks might be. So aside from spans, which can actually be annotated with any form of information you want, we also have statistics, which I'll show in a bit. The other remarkable thing that you can achieve is note that the front end is serving a HTTP request, but we're also tracking this thing not only across processes, but also this is actually a gRPC call. So we're actually tracking it across different types of transport media. So you can get a better picture of everything, regardless of what frameworks you're using or what transport mechanisms. And to complement the tracing that we have there, GCP will actually provide a lot of very basic metrics about the machines that you're running. So we collect all these for free, they're on by default. You can actually use these metrics to perform auto scaling, and you just have to set thresholds. But if we look in here, I have a send stats function which takes some information, but what it's essentially trying to do is log how long it takes each kind of HTTP request to take. And then, how long each type of HTTP request takes and what the return code was, so that I can monitor that. That was helpful. So these are custom metrics that I dropped into my code, and I can group that by status. And GCP actually provides, via a tool called Stackdriver, a fairly easy way to mess around and query the metrics that are exported by the applications that I write. There is one extra thing that I'll point out, is that and it's a hint towards the idea that embracing your cloud platform can actually yield benefits. There is, at no point in here am I providing any kind of credential to the pod or container or my binary to authenticate with GCP. That's because the platform is capable of transparently providing credentials to those pods, and thus means that you can administer permissions and things via the control panel. So simply by showing up on in the right cluster with the right configuration, the application gets the credentials that it needs. It also means that from a management perspective, things can be handled by other folks, or security can get a better perspective. So monitoring itself can also actually provide a full alerting suite, which you can then attach to anything like PagerDuty or something if you wanted to actually start going down the road of full-blown SRE, or at least monitoring and getting alerted when things are in an unhealthy state. So that's kind of a quick whirlwind of the most apparent pieces that of at least GCP that you can adopt kind of regardless of what it is you're building, that'll yield some benefit as a developer. We'll show off one other fun piece, which is I can actually get a breakdown in a very visual way of what traffic is hitting my endpoints and what my different deployments consist of. So Australia obviously being wrapped up in here. and I can isolate individual ones, or in the case of the Americas, United States, provides a very useful tool for breaking down where your traffic can be coming from. So if we figure out that, it likely won't register anything of use, considering these requests are quite small. Yeah. Yep, as expected. Cool. So just to summarize and provide some time for questions, the cloud platforms can provide a lot of different ways to scale your application fairly easily, allowing you to focus on the things that you actually care about, which for the most part should be the code that you're writing, the tool that you're building. And it's worth mentioning as well that if you have a stable workload, in GCP at least, if you're running a VM for, say, an entire month, you get an automatic discount. If you're willing to commit to a year or 3 years, you get an even bigger discount. So the on-demand pricing is one thing and what a lot of people judge by. It's worth taking a look at what pricing you can achieve, particularly if you're looking to use cloud platforms for a full-blown production deployment that a company is going to depend on. Azure and AWS provide similar mechanisms as well, with similar discounts as well. The other thing that, a different way of thinking about these applications that we're building means is that we get to express what they require in documented ways and useful ways. So it's not just writing a list of system requirements in a README. You can express it as a Kubernetes deployment, which you can then give to a cluster, and it will go and provision those pieces for your application. We can also do things like achieve reliability objectives by forcing onto the cluster that you're only allowed to remove so many pods during, say, an upgrade, or you must make sure that these things are always available. Adopting a particular platform means that you can get a lot of nice integrations. There is the vendor lock-in argument, which I completely appreciate. And before anything is ever explored, it should be weighed up, how much are we going to depend on this thing and how hard would it be for us to get out of it? Things like open census and open telemetry, while GCP provides a really good integration with that, ultimately it's a front end to it. And there are plenty of open source or other commercial solutions that you can view that data. So adopting it is a relatively cheap thing to do. It should have minimal performance impact on your application as long as you don't leave full tracing on while it's in production. And it should be universally useful regardless of which provider you go to. Even if it means, say, on another provider, maybe you need to roll your own viewer or collector. It obviously is an expense there. And I will just highlight for those that want to play, definitely look into your platform of choices options around, say, cheap environments. So for GCP, those are preemptable VMs, and as long as there's capacity, you'll get one. In AWS, I believe there is spot pricing. So basically you nominate how much you're willing to pay, and the platform will give you a VM for as long as that price is fair to them. And I'm not sure what actually it does. But it's definitely worth exploring because when we build applications, they get their usefulness, if it's very good, they become very useful to people, ideally, and then people start to depend on them. And suddenly you have this dependence that can swing hard against you should there be issues. So having the ability to gracefully upgrade or gracefully scale out at a moment's notice is a very useful tool to have. Even if you fully document your environment in, say, Kubernetes YAML, you can have a complete failure and bring up a new environment relatively quickly compared with building servers from scratch that 10, 20 years ago was just the dumb thing. And automation, things like Chef and Ansible were a rarity. All right, I'm happy to, I got through that a bit faster than I expected. So I'm happy to field any questions that folks might have about anything that I just rambled about. Or anything in my work at Google that I can answer, or anything about SRE or infrastructure in general.
I have a question. So, what do you recommend for people who are new to this cloud stuff? Where do you recommend people go to learn more about this, so you can mess around and do stuff with it? What do you recommend?
So I've always been a learner by doing, so it's always good to have a project goal in mind, in my view. So if you have an application, or you want to spin up a Plex server or something, just instead of on your local box, do it in a cloud environment. So starting with that sort of, I want to run a thing, I think is a really good place. And then suddenly you spin up a GCP account. There's some free credit. I think AWS gives you some free credit as well. And just mess around with it. The Kubernetes project itself, which is kind of the modern embodiment of cloud, actually has really good documentation. It can be very tough initially, but mainly because there are so many knobs. But you can get a really basic environment up and running with some YAML, and it's not a whole lot of it. I'm going very well, Bob.
Alright, we'll hang around for a couple more minutes just for any other questions.
They pay my salary. The reason that I favor GCP is largely because there's a couple of niceties that you get for free. Well, not necessarily for free, but I think they're worth it. There is a very large focus in GCP around developer tooling. So I think the CLI experience in, say, working with Google Cloud is very good and consistent. The GKE experience of running Kubernetes, I think GCP has one of the best offerings in the market, largely because there are a lot of niggles with other providers that, particularly around Kubernetes networking, that GCP does not suffer from. There is also the fact that Azure and AWS, in terms of the networking that they do for all of their VMs and all their traffic, AWS and Azure build their data centers in a relatively isolated way. So if you have a customer, you are pushing traffic out to the internet, to the public internet immediately. Whereas in the Google world, if you have your stuff hosted in the US, but you have a customer in Australia, then Google will actually ingest the customer traffic in Australia. We will carry it over a network that we manage to the VM that needs to be hit. So we have a better visibility into traffic, how much traffic is flowing over those links. As an example, we actually do expose this sort of information to customers. It is enabled. Nope, that one is not enabled. So mine is relatively minor because I do not have that much cross-zone traffic, but we'll actually show you the network level packet loss that you are experiencing between VMs and things running in different zones. We also show latency between VMs within the project. And at the moment, the only measurable thing is being within the same zone, but we'll actually expand that out to multiple zones if the need arises. So, and I think for the last point, I think for the most part, GCP, you can usually mess around and it comes out cheaper than the other providers. Not in all cases, but at least for my personal stuff, I've found that it's relatively easy to make it cheaper. In terms of working from home for Google, so I think the Bay Area has been in, I've lost track of the days. We've been doing this since about early March, and we have not had any issues at all. So we, as an SRE, we do not have that much of a reason to go into the office as an absolute requirement to do our jobs. All of our tooling works remotely without us having to do anything, no VPNs or anything. And we've already needed to establish good remote work etiquette because my team has a sister team in Dublin, and we need to do our communications on through chat and video conference enough anyway that it's that we're not new to it, and to keep our sister team in the loop. I think all that's really changed is that chat has become significantly more important, but it's also benefited both us seeing what Dublin side is doing day to day, and what they get to see what we're doing day to day as well.
All right. Well, I think that will do it. Thank you so much, Dave, for spending your late night hours over there giving us a talk. I really appreciate it, and I'm sure the rest of the chat. Oh, we have one more question in chat.
Something to do cloud app with. So it's worth pointing out that I think any app, there's no such thing as a cloud app, essentially. There is things that are better suited to be broken into different pieces that can be made more compatible with a cloud. There's a lot of interesting machine learning APIs that I haven't been able to play with. My kind of pet project of late is I've been trying to build a video transcoding pipeline using as much of Kubernetes as possible so that I can aim it at my video library and just have it churn through it using preemptable VMs and also make it resilient so that if there is no capacity in a particular location, it'll spin out into different zones where there is capacity, and just continue churning through the work. And that's going to be my pet project. I will point out as well that Kubernetes has full support for these things called jobs, which are kind of one-shot things. So you can actually use it as kind of like a cron scheduler. It actually has a built-in cron scheduler as well. But instead of doing a shell script, you can do a full-blown container. But yeah, by all means, I think most of the APIs are well documented. If you have any questions, feel free to reach out. As I said at the beginning, I am DF on Slack, and if you have any questions, I'm more than happy to try and answer them.
All right, cool. All right, well, again, thank you so much, Dave, for taking some time out of what is late night over there in the Bay Area. Thanks, everyone, for watching. Reminder, on Tuesday, we have a the Parser Combinator talk with Max Bow at our usual time of 5 p.m. So make sure you come along. But other than that, thank you so much for watching, and we'll see you guys later.
Thanks for listening.